MLflow is one of the oldest and most widely used tools for experiment tracking and model registry. MLflow 3 was recently released with a lot of cool features related to GenAI, observability and evaluation, and seriously improved documentation. In this video, I'm going to talk about MLflow experiment tracking, which is the backbone of everything that happens within MLflow. Welcome to the third lecture of our free MLOps with Databricks course, and I will be talking about getting started with MLflow. The main focus of this lecture is experiment tracking, and in the follow-up lecture, I will talk about logging and registering models using MLflow. Let's talk about MLflow components first. MLflow tracking is a centralized repository that logs machine learning models and the parameters, metrics, and artifacts. Model registry is a centralized model store that allows to manage model lifecycle, add tags, aliases, and new model versions. There is also MLflow evaluation, a set of tools to facilitate model evaluation for GenAI applications and also for standard machine learning. And there is also MLflow tracing that enhances LLM observability in your GenAI applications. Experiment tracking and model registry have different backends. Experiments can be found in a workspace, while models are registered in Unity Catalog. There is also the old way of registering models in the workspace, but it is a legacy, and we are not going to cover that. Experiments in MLflow are the main unit of organization for ML model training runs. All MLflow runs belong to an experiment, and each MLflow run corresponds to a single execution of model code. All MLflow runs are logged to active experiment. MLflow experiment can be created by using MLflow create experiment or MLflow set experiment commands. Let's now deep dive into the code. I will be covering Lecture 3 MLflow experiment tracking notebook. We are running it in the VS Code, so let's start with running the cells. In this lecture, I'm going through Lecture 3 MLflow experiment tracking notebook. Let's start by running the first cell. There is a function called isDatabricks, and it's checking whether there is Databricks runtime version environment variable is present. It is present if we are running code on Databricks, but we are running code locally, so we don't have it set up. And the tracking URI is also set to the local file path. That's actually not what we want. We want to use Databricks MLflow instead, which must be pointed to our workspace. We have a trick for that. We are using the load.env function, and what it's doing is taking our .env file where we specify the profile, and it uses the value specified here as an environment variable. Why do we set this specific profile? Well, that's a profile that we use to authenticate to Databricks. We can go to this Databricks configuration file, and we have a default profile which is empty, and we have profile with this name that is specifying what host it's using. So you can notice that the tracking URI must be Databricks / and the profile name, and we also need to set registry URI, even though we are not using registry yet. Starting from MLflow 3, it's also important to use this command even if you're just doing experiment tracking. So let's run the command, and we can see that we have the correct tracking URI now. Let's set the experiment. So we create a new experiment called shared Marvel demo, and we also set experiment tags, repository name, and our repository name. And that's an experiment that we see here. I wanted to show you how you can inspect any Python object by dumping all the attributes in a JSON file. So we created a folder called demo artifacts, and I'm using JSON lens to look at it. So let's use the light mode, and we can see that there is experiment ID, there is a name, there is artifact location, which is Databricks. We have the lifecycle stage, we have creation time and the end time. We have the owner ID, source name, email, and the experiment type. That's how the experiment object looks like. We can get experiment by experiment ID, so we'll get the same object back. But we can also search for experiments. You can search using different types of filter strings. So for example, we actually set a tag before, and now we can search for experiment using the tag. And since we just had one experiment with that tag, it just finds it. Let's start MLflow run. We can start a run using MLflow start run command. It's pretty straightforward. And it will create an active run. We can get the active run and see its attributes. We have the run name, we have the artifact URI, we have the source name, source type local. We are running it locally. But if we were running it using a Databricks job, it would actually specify the job where it's coming from. Or if we're doing it in a notebook, it would specify a notebook here instead. Well, let's end the run, and there is no active run anymore. So the active run is none, and it's true. So experiment now can be found on Databricks. Let's go there. And this is the run that we have. Well, we didn't log anything really. We also don't have any artifacts here, so it's logical, we didn't do much. Now let's start the run called Marvel Demo Run, and we pass git sha to it. It's actually pretty useful because we can track different experiment runs based on the git sha. And right now we hard coded, but we can pass a real value to it, and that's what we're gonna do in the lecture about deployments. So here we log parameters and log metrics, and because we use the with clause, it ends the run as well. So you can see that there is no active run. Let's view the experiment again, and we can see that we have metric now, the metric 1, metric 2, and we have parameters, exactly what we logged. Let's try to get the run information. So we save the run ID into a variable, and we can now get the run by run ID, and we have run info. It's a lot of stuff in here, and again, let's dump it into a JSON file and review how it looks like. We have info, data, inputs, and outputs. Info contains artifact URI, end time, lifecycle stage, experiment ID, run ID. That's not a Databricks run ID because we don't have any. It's just a MLflow run ID. We have run name, start time. We have metrics and parameters, and we also have tags. Some of the tags are created by us, but some of the tags are created by Databricks. And depending on where you run your code, whether it's from a local machine or inside Databricks environment, it will create different tags. It will also create a tag if it runs in a Databricks job. What job did it come from? Now we can print run info data metrics and run info data parameters. They are part of this run info dictionary. And we can also search for run just as we search for an experiment. Let's try that. And we have this run back. And there is just one run because we didn't have, because we just filtered for the first one. That's what we did. But there are probably more of them already because I ran it multiple times. So let's start the run with the run ID. Basically, we are reactivating the old run. And let's try to add some information to it. So for example, we are now trying to log parameter type, which we already had. So we already had Marvel demo, and now we are setting it to Marvel demo 2. And we can't do that because that value is already there, so it's supposed to fail. A funny part, it actually fails in the VS Code, but when you do it in a Databricks notebooks, it doesn't fail, but it also doesn't actually set the new value. That's a good thing. So you can't overwrite it later if you want to, but you can set new things. So let's set a new parameter, purpose get certified. By the way, it really will help you to get certified for ML Associate or ML Professional Databricks certifications because it covers a lot of MLflow pieces. So we can view our experiment again, and we can see that now we have a purpose parameter. We didn't have it before, and now we do. And that's what we did with reactivating the run and adding a new parameter. You can also add new metrics or other things that you like. Let's start another run and log other things. So we start a run with a run named Marvel Demo Run Extra, and we will log metric 3. We'll also log a metric under the same key but with different steps. We will log artifact MLflow meme. You can see the meme. It's amazing. It's Marvel themed, obviously, just as we like. And we will also log text, dictionary, and artifacts. So we just log the whole folder that we just created. So let's run it. And we started the run, but we didn't end the run yet. So because we haven't finished logging things. So let's log a figure. Let's plot, let's log images. And now we ended the run and we can go and look at the experiment. And this is the run we created. And we have metric 1 and metric 3. We have a model metric that is displayed here, and you can see it per step, just some random stuff really. We can also see artifacts here. So we have the whole folder, demo artifacts, and we have images. So these were dynamically created. We have our meme in two places because we log the whole folder, but also the meme separately. And that's how we can find all this information. And it's not just we can find it in the UI, we can also download it back if you want to. So we can search for runs. Just as we can search for experiments, we can search for runs in way more complicated ways. So filter strings support a lot of different ways of searching for things. You can search by metrics, tags, run names that have certain pattern. So we can try to search for the run. And let's see what the runs is, and it has this one record and that matches this profile. Now we have all these runs, we can load the dictionary back, the one that we logged. We can load the image. We can download all the artifacts. Let's do that. And we got a folder, download artifacts with all the artifacts. Pretty cool. And the last thing I wanted to show you is a nested run. It's very convenient for hyperparameter tuning when you are looking through a lot of different hyperparameters and you want to log all the information about the runs and then search for them. That's how you do it, and that's gonna all be in one place. So let me run this cell. We're not going to talk about hyperparameter tuning here, but the idea is the same, that everything is presented in the same place. So let's go to the experiment again, and we have this top level run and sub runs that belong to it, which makes it easier to search for them. Thank you for watching this video. By now you have a much better understanding of what you can do with MLflow experiment tracking. In the next lecture we are going to the next logical step, model logging and model registering. Stay tuned.